Okay, page 3. In the page 154 reading, they talk about the Fibonacci sequence, which is this sequence here. If you look at it, you might be able to guess how it's formed, and if you read the book, you definitely know how it's formed. But if you look at any two neighboring terms, you can see that adding them will create the following term. So 2 plus 3 is 5. 8 plus 13 is 21. This is a sequence which occurs in nature in size of shells and things like that. So human body, size of the human body, proportion of the human body. So the general term means, how do you write this in terms of the term? So like, for example, let's take the term 1, 2, 3, 4, 5. So we'll take this term here. It's the fifth term. The fifth term is actually the sum of the fourth term plus the third term. So what we could write is something like u of n is equal to u of n minus 1 plus u of n minus 2. Okay, so that's how you would write it in a math formula. Why is this formula here an arithmetic sequence? We know it's a sequence. Why is it an arithmetic sequence? Well, because you see that the separation between all these terms is a common number 3. So to get one number from one number to the other, you add 3. When you add or subtract a number to get the following number, it's an arithmetic sequence. So because maybe we could say the difference between the numbers is always same, is always the same. Okay. What is the algebraic formula to find the common difference d? Well, we could just say that d is equal to u of n minus u of n minus 1. Right? We could take any one of these terms and we could subtract off the previous term and we'll get the common difference d, which is the distance between one number and the other. In an arithmetic sequence, the blank term is the arithmetic mean of the blank and blank term. So if you read the book, what this is saying is that any one term, like let's say the 8 is the arithmetic mean of the two neighboring terms here, the 5 and the 11. So if you take the average of 5 and 11, you're going to get 8. That's the way arithmetic sequence works, and that's kind of why it's called arithmetic sequence. So in an arithmetic sequence, the middle term is the arithmetic mean of the previous term and the next term, or the following term, or something like that. Okay, and so the formula to get the nth term of a sequence is this. So you take the first term and you add n minus 1 times d. Okay, so for the sequence 2, 5, 8, 11, blah, 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 if u sub n is 14, which is that, then what is u1, n, and d? So u1 would be the first term, which would be 2. N would be the nth term, and in this case we're saying the nth term is the 14, which is 1, 2, 3, 4. It's the fifth term, right? And then d is the common difference, which is the distance between each of these numbers. It's 3, the difference between these numbers. Okay, now page 156 reading on C example 2. Okay, that's to give you a little bit of guidance here. Number 1, find the 10th term of each of the following arithmetic sequences. Okay, so now we don't have to like do a lot of work figuring out the 5th term and the 6th term, the 7th term. What we can do is we can just look at this and then we can figure out that u1 is 19, right? D is equal to the difference between each of these. They're already telling us an arithmetic sequence, so we just need to look at one. The difference is 6. And n is going to be 10 because they said that we want the 10th term. So it would be u10 is equal to u1 plus n minus 1 times d. And that would be, let's just fill those numbers in. u1 is 19, n minus 1 is 9, and d would be 6. So you could just multiply that out here. Okay? And then, let's see, B. So in this case, for B, U1 is 101. N is equal to -4. That's kind of tricky, right? It's not a positive number. We're adding a -4 each step, okay? And so you could, and then, oh, I'm sorry, that's D. And then N is 10, just like it was before. So to calculate UN in this case, you would use the same formula, except now D would be -4 and U1 is 101. Then finally, U1, in this case, would be the first term, 8. And then D is equal to a positive 1.5, right? Because the difference between each of these is positive 1.5. And N would again be 10. Okay. So you can calculate that out. You can use your calculator if you want to. It makes it easier. Consider the sequence 6, 17, 28, 39, 50. Show that the sequence is arithmetic. Well, we know it's arithmetic because 17 minus 6 is 11, and 28 minus 17 is also 11. So the difference between each of these pairs of terms is always 11. So that proves that it's arithmetic. Find its 50th term. The 50th term we could find by saying u of 50 is equal to u1, which is 6, plus n minus 1, which is 50 minus 1, times d, which is 11. And on a test, you probably always want to write out the formula, which they gave right here. Write that out as the first thing. I'm not doing it here because there's not too much space, but on a test you would always want to do that. In case you fill in the numbers wrong, you at least get credit for using the right formula. Find the formula for its general term. Oh, and they just asked it here, right? I skipped over B, and that's why I didn't do it. So find the formula for its general term. Oh, I'm sorry, that's not it. So find the formula for the general term. You would put un is equal to 6 plus n minus 1 times 11. Okay, so it would be almost the answer for C. D, is 325 a member? So let's see, they're not telling you what member it would be, so you could assume that 325 is use of n, and then you can figure out if you can get a whole number n that works out right here. So you have to do a little bit of algebra here. You would get 319 equals n minus 1 times 11. Divide 319 by 11. And is 319 divisible by 11? As a matter of fact, it is. It's 29. So n minus 1 equals 29, n equals 30. So yeah, 325 is a member of this sequence. It's the 30th member, in fact. N equals 30, right? Is 761 a member? And so you just do the same thing. You do 761 equals 6 plus n minus 1 times 11, and then you do the algebra and figure out if n is a whole number or not. If it's a whole number, then yes, it is a member. A sequence is defined by, and they give us a formula here, prove that the sequence is arithmetic. Well, just by the format, we can tell that it is arithmetic because we know that to find an arithmetic sequence, that it's in this form, and we can see that it is in this form, right? We can see that there is a something multiplied times n, and there's another value there. Okay, so yeah, we're okay with this. Okay, if you want, you could figure out what exactly u1 is here, and then you would find that it's arithmetic. B, find u1 and d. Okay, so u1, and then we're going to go through and kind of prove it. So let's see. So we can see here that, let's see. What we'll do is we'll multiply this out, and then we'll equate the two. Okay, so we can see that there's an nd term here, and there's a 3n term here. So we can see already that d is equal to 3, right? And then the remainder of u1 minus d and -2, those are equal to each other. So that's the other part of it. Okay, so if d is If d is 3 and u1 minus d is equal to -2, then u1 minus 3 is equal to -2. That means u1 is equal to 1. Okay, so we found that u1 is 1, and we found that d equals 3, so we've solved that. Find the 57th term. Okay, so we could, let's see, u57 is equal to 3 times 57 minus 2, so that's just algebra, right? D, what is the largest term of the sequence that is smaller than 450, and which term is this? What is the largest term of the sequence that is smaller than 450? So what we could do is we could put 450 in there, and then we could approximately find out what n would be in this case. Okay, it would be 452 equals 3n. 452 divided by 3, n would be about 150.7. Okay, so in this case, the 450 is not a member, but there would be something right before 450, which is a member. It would be n equals 150. Because if 450 were a member, its index would be 150.7. Okay, so how do you find the number that's immediately preceding 450? You would just take n equals 150, and you would multiply times 3, and then you would subtract 2, and that would give you the number 448. So the answer to this would be 448. Okay, now number 7. Find k given the consecutive arithmetic terms. So we have 32, k, and 3. So we assume that this is an arithmetic sequence. Now remember, one of the things we said was that the distance or the difference between the neighboring terms is always the same number. So like 32 plus d, it would be equal to k, right? 32 plus d would be equal to k, and also k plus d would be equal to 3. Okay, so using these two equations in algebra, we can figure that out. So like, for example, k equals 3 minus d. 32 plus d is equal to 3 minus d. And then so basically 2d is equal to negative 29. So d is equal to negative 14.5. Okay, and so let's check that. If d was negative 14.5, in 2 steps it would be 29. And yeah, that sounds right. Okay. Now what about c here? K, the first number is k plus 1, next number is 2k plus 1. Third number is 13. The distance between these, again, it's the same factor d. So I would have k plus 1 plus d equals 2k plus 1. And then I also know that 2k plus 1 plus d is equal to 13. So using these two equations, we can figure out what k would be. And in this case, it would be, let's see, we could simplify this top equation, subtract k from both sides. It would be k here. These ones would cancel out. So we would find out that actually k is equal to d. Okay? And then if we know that k is equal to d, then that makes this pretty easy. We have 2k plus 1 plus k, which would be 3k plus 1 is equal to 13, so that means that 3k equals to 12, and then that means that k is equal to 4. So we know that k is 4, we know that d equals k, so we know that d is also 4. Okay? And then the last one would be e. So we have k squared, and k squared plus 6. So again, we just do the same thing. K plus d is equal to k squared, and k squared plus d is equal to k squared plus 6. And hey, what do you know? If k squared plus d equals k squared plus 6, we already know that d equals 6. This kind of looks scary, but it's not really that bad. K plus 6 is equal to k squared. Now we have a quadratic. So if we have a quadratic, what we probably want to do is make it equal to 0. So k squared minus k minus 6 is equal to 0. And then we just need to find the roots of that to find what the solutions for k are. It would be, I think there's two solutions. It would be negative, k could be -2, or it could be +3. It would be the solutions to this, right? Okay. Page 157 reading, please see example 3. Now find the general term un for an arithmetic sequence with, and they give us a couple different things to look at. We're just going to do A and C. So find the general term if u of 7 equals 41 and u13 equals 77. Okay, so the trick here is to use these two terms to figure out what d and n are, or what d is and u1 is, and once you figure that out, the rest is easy. And actually, it looks kind of maybe difficult, but actually we just use the formula we always use here. u7 is equal to u1 plus 7 minus 1, which is 6, times d. And so that's one of the things we know. And the other thing we know is u13 is equal to u1 plus 12 plus 12 times d. And the u13, of course, we just found out is 77. And the u7, we already know it's 41. So now we have two equations and two unknowns, here and here, and we can use algebra to figure out what this is going to be. So like, for example, this one would be we could solve for u1, 41 minus 6d, and then we'll just put it in here. We'll substitute it in for u1, 41 minus 6d plus 12d. Oops, that's a mess. 12d equals 77. Okay, and then you could just combine the d's. Instead of 12d minus 60, you would just have 60. And instead of 77 on one side and 41 on the other, you would have about 36 equals 6d. So d would be equal to 6. And then once you have d equal to 6, you'll know that u1 is equal to, I think, 5. Okay, so the general term would be un is equal to 5 plus n minus 1 times 6. Okay, and that would be the solution for A. Now C is, you do the exact same thing, but the 7th term would be u7, right? And the 15th term would be u15. So you would do the exact same thing we just did, except for now you have different terms. You have u7 equals 1, and you have u15 equals -39, but again, you have to do a little bit of algebra to find the answer there, okay? But if you just find the equations that you need to simplify from, you get almost all the points. Okay, so now 9a. Insert 3 numbers between 5 and 10 so that all 5 numbers are in an arithmetic sequence. Okay, so that would be, you know, if it was 4 numbers, that would be easy, right? Because then it would be 5, 6, 7, 8, 9, 10. Unfortunately, it's insert 3 numbers. So we need to find 3 numbers that are the exact difference between each other. So we could have like 5 plus, and then so if there's 3 numbers, that would be 5 plus 4d is equal to 10. Okay, because if there's 3 numbers in between, 5 something 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 10, then we know we're adding d. Let's see, 1, 2, 3, 4 times. So we're adding d 4 times. So we add d 4 times to 5, and then we'll get 10. So the answer to that would be 4D equals 5. And so D is equal to 5/4, right? Okay. So that is the answer for A. Okay, after you take a look at example 6, then let's tackle this word problem here. Now when you do these word problems, we'll see that why it might be a little bit tricky. But don't jump to using the equation that we learned. You can just like write it out first, okay? Because usually these word problems won't have huge values of n, at least at the beginning. So there's a car factory. In the first month, it makes 5 cars. In the second month, it makes 13 cars. And in the next month, it makes 13. And the next month, it makes 13. And next month, it makes 13, etc. Now, they want to know how many cars are made at the end of each month. So the first month, you've made 5 total. The second month, you've made 18. The third month, you've made 18 plus 13, and then for the fourth month you'd have 13 again, so we'll just use the calculator and figure that out. Okay, so we have this sequence here: 5, 18, 31, 44, 57, and 70. Explain why the total number of cars made after n month forms an arithmetic sequence. Well, if you look at this, arithmetic sequence means that the difference between each of the neighboring numbers is the same number, and in this case we can see that the difference between two neighboring numbers is always 13, so that's why. Okay. C, how many cars are made in the first year? Okay, so that would be, if we extended this all the way to 12, then that would give us the whole number. In 6 months, we can make 13 cars per month. We would add 13 times 6 to that to get, after 12 months, that would be 78 plus 70, which would be 148, right? Okay, so how long is it until the 250th car is manufactured? Let's see if we can write a general term formula that would give us this sequence here. So if we put U1 of 5 and D of 13, would that give us the right number? So we put in n equals 1, that would give us 5, yeah, that's right. Put n equals 2, that would give us 5 plus 13, yeah, that's right. Okay, so I think that since we made it match two numbers, it should be right. And so now let's do this. We're going to say, okay, how do we get 250? How do we get 250 cars? So that would be 5 plus n minus 1 times 13. So that would be, we need to do a little bit of algebra here, and we don't have too much space to do it, so I'll just talk you through it. 250 minus 5 would be 245. Then 245 divided by 13 would be 18.8. So we'd have 18.8 equals n minus 1. And then what would n be? N would be about 19.8. So to get 250 cars, you would need to go past 19.8, so you would have to do 20 months of manufacturing, right? In the 19th month, you would have slightly less than 250 because you have to have 19.8 months to have 250 cars, okay? All right, number 2. Valeria joins a social networking website. After 1 week, she has 34 friends. At the end of 2 weeks, she has 41 friends. At the end of 3 weeks, she has 48, and after 4 weeks, she has 55. Show that the number of friends forms an arithmetic sequence. Well, we can see that the difference between each of these is always 7, so that is the definition of an arithmetic sequence. Assuming the pattern continues, find the number of online friends Valeria will have after 12 weeks. Okay. So let's try to make the general term formula. And we'll put UN is equal to, and let's say that first we'll use 34 here, and then we'll have n minus 1, and then we'll have the D of 7. Now does this work? Let's try to get the second month's number using this. So we have 2 minus 1 is 1, times 7 is 7. 34 plus 7 is 41. Yeah, that works. So I think that's right. So after 12 weeks, we would put 12 in for n, and that would be 12 minus 1 times 7, it would be 11 times 7, which would be 77. Oops, not 777. It would be 34 plus 77. So it would be 111. So U12 would be 111. And how many weeks will Valerie, after how many weeks will Valerie have 150 friends? It would be 150 equals 34 plus n minus 1 times 7. And that would be 150 minus 34. And then divided by 7. And then add 1. So it would be 17.5. N would be 17.57. So actually, it would be, week 18. Okay, last one. Farmer feeds his cattle herd with hay every day in July. The amount of hay in his barn at the end of the day is given by the arithmetic sequence, and they give you the formula in this case. So write down the amount of hay in the barn on the first 3 days of July. Well, the first day, let's see, if n equals 1, then U1 is equal to 100 minus 2.7, which would be 97.3. And for n equals 2, it would be 2.7 times 2. Subtract that from 100, you get 94.6. And then basically every day you subtract 2.7. So the next one would be 91.9. Okay. Okay, so every day it goes down by 2.7. So the amount of hay would for the first 3 days would be that. Find and interpret the common difference. The common difference is negative 2.7. And basically it's the amount of hay eaten per day. Find and interpret U25. Okay, U25 would be 100 minus 2.7 times 25, which would be 32.5. So that would be the amount of hay after 25 days. How much hay is in the barn at the beginning of, and by that way, that would be after 25 days, it would be, I think, July 25th, right? How much hay is in the barn at the beginning of August? So July has 31 days. So basically what they're saying is, okay, July 31st would be U31. So if you found U31, then that tells you how much there is on July 31st. At the beginning of August, that would be end of July. So you could just use U31 for that. So U31 would be 100 minus 2.7 times 31. And so that would be that would be 16.3. Okay? And that's it.